We saw earlier in this section that we can build a machine learning model utilizing each single feature and then use the performance of that univariate machine learning model to select the features. We would select those that return the highest performing models. We did this manually, where we looped over every feature and we trained the model and obtained the performance. We can do this much easier with Feature Engine, importing from Feature Engine selection the SelectBySingleFeaturePerformance transformer. For this demo, we're going to load one of the datasets and divide it into train and test, as we normally do. And we're going to use random forests to determine how predictive each feature is. So here we set up a random forest. And then we create an instance of the SelectBySingleFeaturePerformance transformer. If we set variables to none, the transformer will evaluate all variables in the dataset. Here we pass the estimator that we want to use to build each one of the univariate models, and the metric that we want to evaluate. And Feature Engine will do this with cross-validation, so here we need to indicate the cross-validation fold, and then the threshold above which the features will be selected. With fit, what the transformer does is, for each single feature, it builds a random forest, in this case with cross-validation, and determines the ROC-AUC. And then, if the ROC-AUC is higher than 0.5, the feature will be selected. In the attribute Feature Performance, we will see each one of the variables and the ROC-AUC value obtained with the random forest utilizing cross-validation. We can go ahead and plot this importance sorted by value, in this case the most important features at the beginning. And here we can see that most of the features are non-predictive, as their ROC-AUC is around 0.5, which is a random guess. And then in the features to drop attribute, we will find all the variables that will be dropped because the ROC-AUC is smaller than 0.5. With select.transform passing the training set, we will remove all those features from the dataset. We can also do this for regression. We're going to select a regression dataset, the house prices dataset. We're only going to work with numerical variables because this transformer only works with numerical variables. We fill missing values and we divide the dataset into train and test. And now, instead of creating a random forest classifier, we need to create a random forest regressor. We set up some parameters. You can change these parameters if you need. And now we create an instance of the SelectBySingleFeaturePerformance, passing the estimator and the metric that we want to evaluate, the cross-validation threshold, and again the threshold that we are going to consider the limit to selector features. So variables with an R² bigger than 0.5 will be selected, and here for the R², this transformer will consider the absolute value. So features with R² bigger than 0.5 or smaller than minus 0.5 will be selected. With fit, we find the selected features. In the feature performance attribute, we find the variable and the R², and as you can see, it can take both positive and negative values. We can go ahead and plot the performance of these univariate models, so the models that we built with each single feature. These are the R² values of each feature. We can also plot the absolute values of the R², which are the ones that we're going to consider to select features. In the select features to drop, we will find all the features that are going to be removed, and then we transform, we just go ahead and drop the features. In this case, our method was very aggressive because we only retained one feature. In this case, I would go ahead and reduce the threshold and see if I can select more features. You can also use other metrics to select the features, like for example the accuracy or the mean square error. You can also find more details about this selector in the Feature Engine documentation.